Hello, welcome to the Wrocław Jack. I'm really happy that you all came here today. Today our guest is Thorben Janssen, and we are happy that you agreed to our invitation. Thank you for coming.
Thank you for having me.
Everyone new who just came here and wondering what is Wrocław Juk. We are here, we are doing online talks for everyone around the world, and you have the opportunity to win IntelliJ JetBrains license. You just have to be active on the YouTube chat and sign on the meetup in this event. I have to be able to connect your both accounts. During the presentation, Thorben will answer some questions that you have on the chat, and I hope you will enjoy that. Thorben, stage is yours.
Thanks a lot. Yeah, welcome everyone. If you have any questions during the talk, feel free to post them in the chat. I have it open here on my second screen, and I will try to answer them during the talk whenever you ask them. Okay, so welcome to my talk, Cause of Death, Hibernate. Who am I? Well, my name is Thorben Janssen, and I'm an independent consultant, trainer, and author specialized in solving Java persistence problems with Hibernate. You can find me on thorbenjanssen.com or thoughtsonjava.org, as you can see on the screen. And I'm also one of the organizers of the JAG Paderborn here in Germany. Okay, before we dive into today's topic, I want to make one thing absolutely clear. You can, of course, use Hibernate to implement high-performance persistence layers. That's what I'm doing in my day-to-day work. But let's be honest, always talking about best practices and things you should do gets a little bit boring over time, right? So why not take a different approach? Why not have a little bit more fun and break a few things and think about the things that can really become an issue when using Hibernate? And well, if you don't like that approach too much, no worries. After we talked about how you can break the application using Hibernate, I will, of course, show you how you could do it right and avoid these kind of issues. So what kind of problems would for sure get you into trouble with Hibernate or with your application in general? Well, very bad performance is always a thing that users complain about. So we will talk about that. As most of you probably know, this is actually pretty easy to achieve with Hibernate by just putting a few annotations in the wrong places or using the wrong annotations. So we will start with that. Inconsistent results is always something that all users love. And well, if you want to keep your managers and CEOs up at night, then you probably start talking about losing some of the confidential business data that you are handling with your application. So that would be the third approach that we can use to get our application into huge trouble. So let's start with bad performance. And well, just talking on slides is a little bit boring as well. So why not get into the code? And start with a simple example here. So what do we have here? I have a simple example application with a typical online bookstore domain model. So we have authors, books, and publishers. And in this case, I implemented this small Java session here, Hibernate session here, where I get the author with the ID 1. And after I closed the transaction, everything, I try to print out a few information about the author and the books that person has written. In your application, this probably happens in the back end and this in the front end. So let's run this test and see what happens. And while the test is running, I'm taking a quick look at the chat. Yeah, hello and welcome everyone, QA as well. Great that you enjoy the articles on my blog. Really happy about that. And welcome, of course, also to everyone else. So what happened here? Well, you see that the test failed. Why did it fail? Oh, we have a lazy initialization exception. And that's on the author.books association. So what's happening here? Yeah, here we have the author object, and then I get all the books, and then I use stream API to just print out the names of all, or the titles of all the books. So let's take a look at the author entity. Here's the books attribute. It's a typical many-to-many association. And as you can see, I didn't define any fetch type here. This line 38 here is commented out. And that actually means that we're using lazy loading. And that's why we got this lazy initialization exception here. Because when we are printing out this, the transaction is already closed. The entity manager is closed. So Hibernate isn't able to fetch the associated books from the database. And if you start searching for lazy initialization exception on Google, then you might end up on Stack Overflow, where unfortunately you still find a bunch of suggestions that tell you to activate fetch type eager. And well, if we run the test again, then we will see it now passes. Right, great, right? We solved the lazy initialization exception. We look at the log. Let's take a look. What's Hibernate doing here? Well, it executes this statement that actually doesn't look too bad. I mean, we need the author and all the books. So in the from clause, we are starting on the author, join to the book author association table, and then to the books table. And up here, we are selecting all the columns from the author and the book table. Doesn't look too bad. Could now expect that followed a good advice on Stack Overflow or somewhere else on the internet, and that using the fetch type eager was actually a good thing, right? I mean, looks good. But let's go to the next test case, where we had a simple JPQA query that selects all the authors from the database. That one passes as well. That's great. So here we are selecting all the authors, and then we are printing out log messages for each of them, where we just print out the name of the author. Let's take a look at the log output. Here we can see everything's fine, nice. But we are up for a surprise when we take a look at the Hibernate statistics up here, because there we see we're executing 7 JDBC statements. But if we take a look at the log, at the code, we just see this one statement here. So why are we executing 7 statements? Let's take a look. Lots of select statements that get book records from the database. But we don't need the book information here. Well, that's the downside of the fetch type eager that we set here, and that's the reason why using fetch type eager is actually a pretty bad advice. So what happened here? We fixed the lazy initialization exception by getting rid of lazy loading. But in most cases, lazy loading is a great thing. It makes sure that we only fetch the data that we actually need. If we replace the fetch type lazy, which is the default for all too many association, with fetch type eager, then Hibernate fetches the books association every time we instantiate a new author or we get a new author entity from the database. And as you have seen here, it doesn't matter if we will use the books or not. Hibernate fetches them anyways. And this for sure will cause huge performance issues in your application if you ship it to production. Because this is the typical N+1 select issue that you can find in lots of applications, and that is one of the most common reasons for performance problems. So let's get back to the author entity and remove the fetch type eager here. So using fetch type eager is a code smear. Let's be absolutely clear about that. It's a bad advice that you can unfortunately still find on the internet, and you should not use fetch type eager. Yeah, Hubert has suggested up here that we should put the log message into the transaction. That's of course right. That would fix this test case, but it would no longer simulate the situation that we have in a client-server application where this is running in the server and this is running in the client or in the front end. Okay, so I switched the fetch type here from eager back to lazy, and I executed this test case again. Let's take a look at the log. We still see the names of the authors, and now we just have one JDBC statement. And you can see it up here. We are just selecting the author information. And that is the only information that we need in this case here. We've just print out the first name and the last name. But then we're back up here with our lazy initialization exception. And you can see it here already. We now need a different way to fix this issue. And the best approach to do that is to tell Hibernate that we will need the books association and that it shall initialize it. And the easiest way to do that is to use a left join fetch clause. As you can see, from a syntax point of view, it's pretty similar to a left join, which you probably used a few times already in your JPQA queries to join two entities within a query and then use the initialized or the joint association in your where clause or somewhere else in the query. The left join fetch is a little bit different. The left join fetch tells Hibernate to initialize the association within that query. And that means that Hibernate needs to extend the projection of the query, which is the part there that you're selecting. You can see it up here. Now we are no longer just selecting the author, the columns from the author table. We are also selecting the columns from the book table, which is here book 2 underscore. So here we are selecting title, version, and ID, which are actually the only columns in the book table in my simple example here. And this is basically the same query that Hibernate generated before, but in this case, not because there's an eager fetching and Hibernate knows that it always has to initialize the association whether or not we are using it. This time, due to the join fetch clause, we told Hibernate to initialize it because we know that our use case will use the association. And if we are not doing that, so if we're not doing a left join fetch here, Hibernate will just select the information from the author table as it did down here. So now we have the best of both worlds. We have the initialization of required associations whenever we define that using a left join fetch clause here. And we have the default solution that only fetches the association, the columns from the database that we actually need. And yeah, Lukas, you're right. The fetch type eager is really harmful, and you should stay away from it. Don't use it in your applications. Okay, so let's take a look at another thing, and that is the author books association. This time I start on the book entity. Most developers, when they model a many-to-many association, use the data type list. It is the most efficient one in the Java world, right? So why not use it for our to-many associations? Might look like a great idea. But let's take a look at what happens when we are removing one element from the list. So let's say we have a book that was written by two authors, and we decide that one of the authors was actually added by accident, and we need to remove it. I do that here and just remove the first one. And where you would now probably expect that we are removing one record from the book author table, which models the association between the book and the author, right? Well, no. With Hibernate, we get a pretty inefficient handling of lists as the data type of a many-to-many association. It's actually called a persistence bag, which is an unordered collection type for, used by Hibernate. So what does Hibernate do? Hibernate deletes all records from the book author table that belong to the book for which we remove the association. See it here on the book. We get the list of authors and remove the first one. So Hibernate deletes all records from the book author that belong to that specific book, and then it inserts all the remaining ones. So instead of one statement, we now have 4 statements. One that deletes all book author records, and then 3 statements to add the 3 authors of that book. And well, let's think about this situation if you would deploy that to production. First of all, it would look pretty strange if you need to audit your data. I'm pretty sure if an auditor checks your audit log and finds something like that, that will raise some questions. But at the same time, it's pretty inefficient. Instead of just executing 1 statement, we're executing 4. And it's only 4 because we only have 3 authors of that book. Let's say we would have 20 authors. Then we would have 1 delete statement and 20 insert statements to add the authors to the table. So using a Java utilist here isn't that efficient. And there are a bunch of questions in the chat. I would get into that in a bit. Let me just finish this thing here. So what I'm now doing is I'm replacing the author attribute, and I'm now using a set. So let's go here, make it set updated, and that one is updated. Okay. Run the same test case again, then we can see now that Hibernate now generates exactly that statement that we would have expected in the beginning. A delete statement that removes exactly 1 record from the book author table and not just all of them, and then re-adding the remaining ones. So this is what we would like to see if we're removing 1 element from the many-to-many association. So whenever you have a many-to-many association, like I have here, and you don't need to support duplicate elements in it. So it doesn't make any sense to add an author twice to the list of authors of a book, right? So as long as you don't need to support duplicates, you should always use a Java util set for your many-to-many associations. And yes, the set is a little bit slower than the list, but you will not recognize any difference in your application because you only see a significant performance difference between a list and a set if you are working with lots of elements in that set or list. But because you need to fetch this information from the database, the performance overhead of fetching all the information from the database would actually slow down your application so badly that the performance difference between a list and a set can just be ignored. Wouldn't be relevant at all in that situation. Okay, so let's take a look at the chat and answer a few questions before we get to the next example. So Marek wrote, by fetch join, we will fetch whole data by single query, but this may kill database when we have a lot of data. How to solve this? I work in banking where I have a lot of data. Yeah, that is a downside of the, or potential downside of the join fetch. If we run this again here, then you can see here that we now join the author with the book, or with the book author and then with the book, and that we select everything here. So as SQL works, you now in your result set find the author information as many times as that author has written a book. So if that author has written 3 books, you will find this author 3 times. So the author with book 1, the author with book 2, the author with book 3. That's just how SQL works for these kind of queries. It creates a product. So if you now have a huge association where you have hundreds or thousands of elements in it, let's say you have this association between the the new book and the reviews. And if you look at bestseller in a huge online bookstore, you would see probably a few thousand reviews. Then using a joint fetch clause, as Marek wrote, isn't a great idea. The issue there is that the product gets so huge that it actually slows down your application. In that case, fetching the association in general isn't a great idea. You should better not fetch the association, just get the book and then execute a query that gets the reviews that you actually need. And that would be my suggested approach there. So you would, for example, execute a query that gets a book and then execute another query that gets the first 10 reviews. Instead of just getting the book with all the reviews. Marek, I hope that answers your question. If I should get into more detail on any part of it, then please post something in the chat. Okay. You can consider batching would be the next comment in the chat. I don't exactly know what you mean by that. Considering batching in which case? So in this case here, batching wouldn't help because we need to fetch the information anyways. The only thing that helps here is shrinking it down to something.
I think that was the answer for the Marek question.
Ah, okay.
You have the comments where just people are trying to help him. So yeah.
Ah, awesome.
And yeah, there is a question from the Łukasz. Wouldn't fetch mode subselect work for some extent?
Would it help? Yes and no. That depends on the situation that and the way you query your data. So what would that mean? What we could do is we could set here fetch mode, fetch mode subselect. We could set that here, and that would trigger a query that fetches the books and uses a subselect for it. That could help in Marek's situation in general. Is that the correct log? Like this, and then we need a get result list. And then it's a list of authors, and basically nothing of this example is left, right? Okay, let's explain that in theory. So what the subselect fetch mode does is, if you're selecting multiple records in this query up here, then we get a subselect down here that looks similar to the statement up here, and that basically gets all the books for the authors that we selected before. There are a few things you need to be aware of. First of all these fetch modes behave differently depending on how you fetch your data in advance. And so depending on, do you use a JPQA query, do you use entity manager find, and so on. So that often makes your persistence, the behavior of your persistence a little bit unreliable, but they work in general. The next thing here is that for this case, where we're just fetching one author, splitting it up into two is actually a bad idea. It would be a better idea to use the join fetch clause here and get everything in one. The subselect would work down here, where you then split it into two statements. And yeah, in that case, it could work and solve some of the issues, but only up to the point where your second query doesn't select so many, in this case, books, that query then selects thousands or hundreds of thousands of records. So in that banking example, I doubt that the subselect mode would actually solve that issue. But yeah, in general, it could be an approach that you can try on smaller data models. Okay, what else do we have here?
I think that was the last.
Okay, I think we're done with the questions, right? Yeah. So what was the last example that I showed? This one here. So what we did was we replaced the list with a set. I will revert the change real quick because I want to show you another thing, and that is down here. So a few minutes ago, I told you that a left join fetch is actually a good way to initialize an association if that thing doesn't get too big. So a logical next step would be if you need a book with an initialized list of authors and an initialized list of reviews, would be to just do two join fetch clauses, right? I mean, that's a pretty obvious approach. Well, that resides in a multiple bag fetch exception. As I said earlier, a list, an unordered collection type used by Hibernate is called a bag. So in this case, we are initializing fetching two bags. That is the first one, and this is the second one. So in that case, we are now fetching two bags. Hibernate doesn't want to do that, and we can solve that by changing the data type from list to set for these two associations. And then theoretically, we can fetch the two associations. You can see now the test passed. And here we selected all the columns from the book, the author, and the review table, and we joined all the records here. This works for all associations that don't contain a lot of elements. You need to be careful with that if you have an example like this one here, where you join the reviews to the book. So where you have an association that might contain a lot of elements. As I said earlier, a popular book in a bigger online bookstore often contains thousands of reviews. And join fetching them here would be a bad idea because, as we already discussed, you get the book as many times as there are authors multiplied by the number of reviews for that book. And due to that, it creates a product that grows really fast. Because of that, you find some suggestions online that you should never use more than one join fetch clause. I don't like these hard rules for any kind of coding task or performance optimization. Why? Well, because it totally depends on your domain model and the data that you have in your table model. In a production database, the issue is this left join fetch clause here. It doesn't matter if you fetch a few authors with that thing or not. If you're just join fetching the books with all the reviews, and there are thousands of reviews per book, then this join fetch clause will cause performance issues because the product gets too big. And it doesn't matter if you have 1, 2, or 3 additional left join fetch clauses there. So totally independent of the number of left join fetch clauses that you use in your query, you always need to check how many elements are part of your standard associations. You look at the production data set, and based on that, decide if it actually makes sense to join them or to join fetch them and create this product in your query, or if it's totally fine. We used multiple left join fetch clauses in various customer projects, and it worked totally fine there because we talked about the domain model and we knew, well, they are just 4, 5, maybe 10 elements in that association, and it's totally fine to left join fetch them. But in that case, this would be an issue. You could replace the left join fetch from the book to the reviews with the left join fetch to the publisher, and that would be totally fine. So again, always make sure to double check the number of elements in the association. This one here would for sure cause performance problems in a production setting. But there's a second issue with this one here. So what do I do here? I get the books with all the authors and the reviews. But if you look at the log output, then I just need the title of the book, the first name and last name of the author, and the number of reviews. There is no need to fetch this whole graph of objects with all information about the books, all information about the authors, and all information about the reviews. I mean, you saw that here. We are selecting everything from these tables. But we don't need everything. We just need these few columns I just mentioned, right? So why not take a smarter approach that only gets the information that we need? In this case, I could create a book author review class that contains the title of the book, a string with the joint names or the concatenated names of the authors, and the number of reviews. That would be totally fine to write the log message down here, which is the same one as we had before. The log message actually is easier as it was before, but it prints the same information. So how do we get then these book author review objects? Well, the most efficient way is to use a constructor expression. And you can use that in JPQL. It starts with new. And then you have the fully qualified class name, an opening bracket, and then the list of constructor parameters that you want to use. And that are the columns or return values of database functions that Hibernate uses in the generated or gets from the generated SQL statement. So here we start with the title. And then we use a database function to aggregate the first name and last name of all authors that belong to that book. And then we count the number of reviews. So let's take a look here. So here we have the title of the book. We aggregate the author names, and then we count the number of reviews. And then we can write our log message that the book 2 was written by Max Mustermann, Maria Mustermann, and it got 0 reviews. So we have all the information that we need without fetching this whole graph of entities. You can see it here. We now just select the title of the book, the first name and last name of the author, and we count the number of reviews. So this is the most efficient approach to get these information from the database. Now we talk about that later in a little bit more detail when we talk about the inconsistencies. Let's now take a look at caching, and specifically at the caching of queries. So with JPA, you have two caches. You have the first level cache, which is your persistence context and contains all the objects that you, or all the entity objects that you fetch within your current session. And then you have the second level cache, which is independent of your current persistence context, and where you can actually benefit from multiple calls of your backend. So this is a permanent cache where you put in your entity objects and not just the ones that you worked with in your current session. Hibernate adds a third cache, the query cache. And that one caches query results. And that's the one where I see the most mistakes happening in real projects. So let's take a look at this example here. So we have this query. We are fetching a book with initialized list of authors and initialized list of reviews. And we set the, we activate the query cache for this query here. So after we completed this one here, we would expect that the result of this query is part of the query cache. So if we go down here and do exactly the same, we should get all the information from the cache, right? Well, let's take a look at the log output. Because here we are up for a bad surprise. So where is my first session? Here. So this was the first session. We executed one JDBC statement, which is the query that you just saw in the code. And we put 13 objects into the second level cache. Sounds good. So we put in there, hopefully, the authors and reviews and everything, right? Well, then we should get everything in the second iteration from the cache. But as you can see here, we have lots of queries that fetch books, and then we have queries that fetch authors for a specific book. More queries, and in the end, we have 24 statements. That's a lot. So what's happening here? Well, the query cache doesn't store entities. It just stores references to entities. And that entity reference needs to be resolved when we execute the query down here. So after we executed this one here, Hibernate stored references to all these book entities that we got from this query. And we get these book entities, entity references, when we execute this query again. And that means that Hibernate gets a primary key value for a book entity from the query cache and then tries to resolve it against the current persistence context, which is the first level cache. So Hibernate checks if it's in there. No, the book entity isn't in there. Then Hibernate checks the second level cache, and if it doesn't find it there, then Hibernate executes a query that fetches that specific book entity by its primary key. And that's why we are seeing all these queries up here where we fetch a book entity by its primary key. So the first question we need to answer is, why doesn't Hibernate has the book entity in the cache? And you can see it up here. I didn't activate the cacheable annotation on the book entity itself. So the book entity wasn't cached. Now, by annotating it with cacheable, it's stored in the second level cache. So it should be better, right? Let's take a look. So now we're down to 12 statements. Well, that's way better than the, I think it was 24 in the previous run. But, right, let's face it, in the first iteration, we had one query and put everything into the cache, and we still have 12 statements when we use the cache. Why is that? Well, if you take a look at the log output, then we can see that we have lots of queries that get data from the author table and always for a given book ID. And the issue here is that by default, the association between the book and the author doesn't get stored in the second level cache. So what Hibernate does in the second level cache is it stores the so-called dehydrated form of an entity, and that is a list of all its attribute values. Well, this association here is stored in the book author association table, which is not part of the book. And due to that, Hibernate doesn't store it in the second level cache when it stores the dehydrated form of the book entity. If you want to store it in the cache, then you need to annotate it with the cache annotation, as I already did down here for the reviews as well. So now Hibernate puts the association between the book and the author into the cache, and the association between the book and the reviews. So we'll run the test again. We can now see that we are down to 6 JDBC statements. Why? We are still getting the authors by ID. A few seconds ago, we got the authors by the book ID. So what's going on here now? We activated the cache on the association, but if we look at the author entity, the author entity isn't cached. So we need to activate the caching here, and now we can run it again. Now you will see that we got all the information from the second level cache, finally. Up here, 0 JDBC statements and 43 elements from the cache. These 43 elements are the query, the all books, all authors, all reviews, all associations between books and authors, and all associations between books and reviews. And due to that, it's quite a huge number of elements that we are storing in the cache right now. So what did we learn in this example? Well, we learned that caching is a tricky thing. If we activate the query cache, we need to keep in mind that Hibernate doesn't store any entity objects in the cache. It just stores entity references and then resolves these entity references against the first level and the second level cache. And that means that if you activate the query cache for a query that returns entities, you always need to make sure that you activate caching for that entity class. And if you initialize association between your entities, you also need to make sure that you activate the caching for these associations if they are not part of the table that gets mapped by the book. If we would have a many-to-one association defined on the book entity, then that one would be automatically part of the dehydrated form of the book entity, and it would be part of the second level cache, because the foreign key column would be part of the book table. That's not the case for the many-to-many and one-to-many association. There, the foreign keys are stored somewhere else, in this case in the book author table, and in that case in the review table, and you need to annotate these associations with add cache. There was a question by Adam. Why does Hibernate treat set and list differently? Yeah, that's a good question. Because Eclipse Link doesn't do that. At least not in the way that Hibernate treats them differently. It's a question that's best answered by the development team. I and I'm not part of the development team. I asked that once in the past, and the explanation that I got was that this is because a set can contain duplicates, and the elements in a set need to implement or provide a meaningful implementation of the equals method. That's not required in a list. So it's actually a lot harder and not as reliable to check if, or to determine the delta between an old and a new version of a set if we remove, where's the example, when we remove the author here. So when we're using a set, then Hibernate can relatively easily figure out which elements got removed or added to the set, because each element in that list needs to provide a meaningful equals and hash code implementation. In a list, that's not that easily doable, and it could contain duplicates, which would make it so much harder to determine. Okay, then we have another question by Lukasz. Spamming cache annotations may cause some kind of ORM, or will Hibernate ignore them not to exhaust memory? No, Hibernate will keep putting the elements into the cache, and then it depends on your cache configuration, how it cleans up the cache, and if it has some upper size limits and stuff. So the cache is independent of Hibernate. JPA just defines an API for the second level cache, but the second level cache isn't part of the JPA implementation and not defined in this spec as well. So there you nowadays usually have a JCache compliant cache implementation that gets integrated via Hibernate's JCache integration. In general, you should be careful with adding the cache annotation or cacheable annotation. One is JPA, the other is Hibernate specific, to your entity classes. It always depends on your cache implementation, on if you want to determine the exact read-write ratio that you need to actually benefit from the cache. One thing is for sure, using the cache takes time. We can see it here. The cache hits cost us 942,000 nanoseconds, which is way faster than fetching 43 records from the database, but it still costs time. So the same is the case here for the put operations that we did before. So by introducing the cache, we introduce an overhead to our application. And we now need enough read operations that are significantly faster than the database query to make up for this additional effort that we had here with the put operations, and the same with these misses. So when you're activating the cache for your entity classes, make sure that you have a lot of read, but just a few write operations on these entity objects. General recommendation is to make sure that you have 9 to 10 read operations per write operations for your entities. If you have less than that, then your cache will most likely create a bigger overhead due to the whole management effort. Then it actually saves you time during the read operations. Yeah, to get back to the question from Lucas, if you run into an out-of-memory exception or not, then depends on your cache configuration and the cache implementation you are using. That's outside of Hibernate, but it's it's general in general a thing that you should keep in mind. Cache requires memory, and you can run out of it. Another thing you can do with the query cache is to cache your DTO projections. If you remember, a while back, I talked about this book author review class for which Hibernate instantiates an object for each record that it fetches with this query from the database. And the good thing about this constructor expression that creates book author review objects was that we only select the title, the first name, the last name, and count the number of IDs. So that means we only get the information from the database that we actually need for our use case. With the query cache, we can also cache the book author review projection, so the constructor expression that we have here. So similar to the previous example, I run 2 queries that select book author reviews, and then I print them out, and we now take a look at the log output, and we can see here in the second transaction that we have 0 JDBC statements, and that we got all the information from the database, from the cache, and we selected only the information in the first session that we need for our use case. So then we can print out here the log message that we need for our use case. The good thing about this approach is that the objects that you get here are not the same as you get here. What Hibernate does is Hibernate stores the query result, which means Hibernate stores this information up here. So the title, the concatenated first and last names, and the number of reviews. It doesn't store the book author review objects in the cache. That is something that happens afterwards. It's a post-processing step of your query. So Hibernate generates an SQL statement based on this JPQA statement, gets the result from the database, stores that result in the query cache, and then applies the post-processing, which instantiates new book author review values. So that's what it always does for this query, and the same that it does down here. The only difference is for the second iteration, Hibernate got the result set from the cache instead of the database. The rest is more or less the same. Okay, so that would be a quick rundown of the most important things that you should keep in mind when thinking about read operations, some of the most common issues that I see in my consulting projects that actually cause horrible performance issues. There are, of course, a bunch of smaller things, but these are the really big ones. So if you want to let your project fail, these are pretty good candidates for that. So let's sum this up. So to avoid bad performance, you should always use fetch type lazy and then use a use case specific projection for each and every query. So what is a use case specific projection? That can be 2 things. If you're implementing write operations, that would be a query that selects entities and uses join fetch clauses to initialize required associations. If you're just implementing read operations and don't want to change the fetched information, then it would be a DTO projection, because a DTO has way less overhead than an entity object. An entity object gets managed by Hibernate. Hibernate needs to determine if it was, if the entity was changed, if it needs to replicate any of these changes to the database, and all of that isn't done for DTOs. So it's obvious, if you don't plan to change the information, use the DTOs, then Hibernate knows, okay, nothing changes here, and Hibernate doesn't need to perform dirty checks, or doesn't perform dirty checks on DTO projections. Then we saw that we should use a set instead of a list for our too-many associations. We had this many-to-many association where removing an element caused a bunch of statements instead of just one that removed one record. And we saw these multiple back fetch exceptions when we used the list. Both issues disappeared after switching to result set. Cascade type remove is another thing that actually slows down your application. We will get into more details about cascading in a bit. And then we talked about caching, where we saw that the second level cache is really important when you are using the query cache, because both of them need to work together, because the query cache doesn't contain any entities, it just contains entity references, and these need to be resolved against the first and second level cache by Hibernate. And if you don't make sure that your entities are part of the second level cache, then you might trigger an additional query for each entity reference returned by your cached query. Then there's another question in the chat. Is returning ID enough to define equals method? Yeah, the ID attributes are the only ones that you should use in your equals method. Implementing equals in hash code for entity classes is actually pretty tricky when you're working with generated primary keys. If you're working with a business key, it's pretty straightforward. There you just compare the class and use the ID value to check the equality of the two entity objects and to calculate the hash value. If you're generating primary key values, then you should use a static hash code value. And in your equals method, you should compare the type of both objects, the primary key attributes, and if any of the primary key, if the primary key of any of these two objects is null, then the two objects are not equal. That is the general recommendation on how to implement equals in hash code. But you should think twice if you actually need to implement them. Hibernate ensures that it fetches that it fetches the entity object that represents a specific database record only once per session. So there can't be multiple instances of the same entity within one Hibernate session. And due to that, using the standard Java object equals and hashcode method is totally fine as long as you're not detaching your entity objects and then try to compare them for equality. Or if you're not getting entity objects from the client and then trying to merge them or to compare them with entities in your current session. If you're doing these kind of things, then you need an equals and hashcode implementation. Otherwise, please just use the one provided by Java's object class. Okay. So the next thing that can cause a lot of trouble are inconsistent results, or results that at least look inconsistent. How can we do that? Another example of the left join fetch that we talked about earlier. So a common mistake that you can see in a lot of projects is we want to get an author with initialized lists of books. So we use a left join fetch clause to tell Hibernate to initialize the books association. But in this case, we don't want all authors. We just want the authors who wrote the book with ID 2. So because we already joined the author with the books, why not use the book in the where clause, right? I mean, if we take a look at the log output, we don't see any exceptions. The test case passed, and we see here that Max Mustermann wrote book 2 and Maria Mustermann wrote book 2. Doesn't look too bad, right? Well, let's switch this up a little bit and use two join fetch clauses. Or two join clauses. One left join with an alias B, which we then use in the where clause, and one left join fetch. And Now take a look at the log. Then we see that the query result that we saw before was actually wrong. Right? It wasn't wrong, it just didn't provide the information we expected. Because now we see that Maria Mustermann wrote the book 2, 3, and 4, and Max wrote the book 1, 2, and 3. So what happened here? The issue in this first query is this left join fetch. And the intention of a join fetch clause, it's intended to be used to initialize an association, which means we want to get all the books of that specific author. We expect to get a fully initialized association, and Hibernate does that as well. So by using the alias B that we have here in our where clause, we no longer get a fully initialized list of books. We only get the books with ID 2. So here you can see we join from the author to the book, and limit everything to book with ID 2. And that means that when we initialize the books association on the author entity, we only get the books where the ID fulfills the where clause. But that wasn't the intention that we had here. We wanted to get all the books. Because of that, we need 2 join clauses. We need one left join fetch that initializes the association and one left join that limits the query result to the books with ID 2. So now you can see here that we have book 2 that we join here with our author table. But in the select clause, we only have book 4. You see that down here where we join it again. This is something that, yeah, we need to be aware of, where we just need to accept that to implement this query in the way it's intended to be, so where we get all the elements of the association, we need these 2 join clauses. That would be the same approach that we would use if we write this this SQL statement here ourselves and not just use Hibernate for it. The interesting thing is this works totally fine in, this up here works totally fine in a JPQL query, which means Hibernate doesn't throw any exception for it. But if you would try to implement that with the criteria API, then you would actually not be able to do that, because the fetch interface that you would get from a left join fetch clause can't be used in a where condition, because you can't access any elements on this left join fetch clause. That only works on left join interface. That only works on a join interface. Okay, another thing that can cause something that looks like an inconsistency is the approach here. So I first select all the authors from the database. Then I update all authors and change the first name to uppercase and the last name to uppercase. Then I select the select all authors again and print them out. But if we look at the log output here, it looks like our update never happened. If we scroll up here, we see that we actually executed an update that changed first name and last name to uppercase. So what happened here? Well, we run into a small trap with Hibernate. We see here that we executed another query that selects all the authors, which is the same query as we did up here. The issue is that we are working with author entity objects within the same Hibernate session. So when we execute this query here, then Hibernate instantiates an entity object for each record returned by this query. These entities are now managed. Then we run this update statement. That update statement gets just sent to the database and doesn't change any entity objects that are currently managed. And then we run this query again. Hibernate executes it, gets the result set from the database, and for each entity object returned here, Hibernate takes the primary key attribute and first checks if this entity object is already managed. And if that's the case, then Hibernate ignores the record in the result set. That's necessary to ensure that we have only one object that represents a specific record in the database in one Hibernate session. And here, the downside is that we change the data in the database. We get it back with the select statement, but we never see it in our Java code because we are still working on the objects that we got up here. So the data isn't inconsistent, it just looks like it. And we can fix that by adding a flush and a clear before we execute this JPQL update statement. Now you can see that the names are all uppercase. And the reason is that the clear removed all objects from the current persistence context. So after the clear, no entity objects are managed. If you add a clear to your code somewhere, please always make sure that you call the flush method before you execute the clear. Because if you tell Hibernate to clear the persistence context, then it does exactly that. It doesn't check if there are any dirty entities. It doesn't check anything. It just removes the objects from the current persistence context. And that means that if you change anything in between this query and this call of the clear, and you didn't have this flush call here, then you would just lose that change. And trust me, I had to analyze that for a few customers. Finding these kind of things is really annoying, and it might take a while. So please always make sure that call flush before you call the clear method. Another trap that can cause issues with Hibernate is the management of B-directional associations. So in this case, we have the association between the author and the books. So we model it on the author with a map by, which tells us that the books, the book entity actually defines the association and all the required information for it. And we can see it here. This is called a B-directional association because it goes from the book to the author and from the author to the book. So if we now change anything on the author entity object, then we can see in the log file. So here I'm removing the book from the author. But we can see in the log file that we just have select statements. We get the author, we get the book, we get some association information as well, but we are not removing the association. This call here just didn't trigger anything. Why? Because we updated only the referencing side of the entity. You always need to update both ends. If you would just update the owning side of the association, then you would see the delete statement here, but you would have an inconsistent situation in your current persistence context. Because if you take a look at the author up here, then author Max Mustermann wrote book 1, 2, and 3. But if you check the book 1, then it has no author. Why? Because this call here doesn't update the books association on the author itself. What you would need to do is update it on both ends. Or to make it a little bit easier, implement the utility method on your book entity that ensures that both ends of the associations get updated. If you do that, then you can see that we removed the record from the database. And we can see that Max Mustermann no longer wrote book 1, and book 1 has no author. So here can now see, okay, we updated the database. Both entity objects in our current persistence context are in sync. And that's the way to do it. Always make sure to update both ends of the association. And to make your business logic a little bit easier to implement, make sure to provide utility methods on your entity classes that take care of that. Okay, final way to cause inconsistencies is the open session in view anti-pattern. Unfortunately, it's used by Spring by default. Newer Spring Boot versions at least print a warning for it during startup. But still, it's default, and you can find it in a bunch of older Spring applications. So what is the open session in view anti-pattern? The idea here is that we could avoid lazy initialization exceptions by opening the entity manager or Hibernate session in your view layer, which means in your web layer. And then after you instantiated and associated an entity manager with your current web request, you call the business logic, and that one uses that entity manager and just starts the transaction, commits it when it's done, gives you back all the entity objects that you need, and you can then call getter methods to actually initialize the association. And yeah, that works. But it has an issue. You initialize the association by calling another query outside of your transaction context. And due to that, the query that you trigger down here is not running within the context of the same database transaction as the initial query that you did up here. That has two downsides. First of all, it increases the load on the database because you're opening and closing transactions all the time. So one for everything that happened in your business layer, and then the additional query that got triggered by your view layer. And it can create something that you can see here. Based on the stuff that we selected in our business layer, we know that Max Mustermann wrote 3 books. And then in the view layer, we try to fetch these books and print them out. But there are only 2. So Max Mustermann wrote 3 books. These are book 2, book 3. That will confuse most of your users, because these 2 just don't fit together. And the reason for that is here in this parallel transaction. So what I did was, between the select for that's performed in our business layer and the initialization of the association in the view layer, I executed a parallel transaction, and that actually removed the record from the association. So the right approach would be to move this part here into the transaction context. And wait a second. Yeah, it would even be better if you now would need to move it up here. It would be even better if you then initialize the association here instead of just counting it, so that you can then print out the information down here. Otherwise, you still run into the same issue. Okay, there was a question by Lukas in the chat. Why isn't emFlush done in emClear with some method emClear without flush for other cases? What is the ratio of flush plus clear to only clear invocation? Does it depend on specific app logic? I'm pretty sure that's implemented because it's defined like that in the JPA specification. But I can answer the question why it was defined like that. I have no clue. And the ratio between clear and clear plus flush, well, in your business code, there shouldn't be any clear without a flush. Because you never know in your application if there was nothing changed before this flush. Well, you almost never know. The only situation in which you know that nothing has changed is if you annotated the method in which this happens here with transaction new, or requires new. Otherwise, it might happen that at some point you implement a new use case, and within that use case you do something, and then you call the method that does that. Where when you wrote it, you were pretty sure that you haven't changed anything. So because of that, I would say always call the flush, just to be sure that whatever you change in your application, you will always do the flush before the clear. And the flush is pretty cheap here. Costs almost nothing. Why? Well, there are two situations. Either your persistence context is, for whatever reason, empty anyways. Then the flush here space is almost for free. Or it contains entities. Well, then you trigger the flush before before these statements anyways. So before Hibernate executes an additional query, it triggers a flush internally, and this one doesn't cost too much in that situation here. So did I answer the full question? So no, I don't know why flush and clear are two separate methods, just how it's defined in the API. Ratio between flush and clear to only clear would hopefully be only flush plus clear and no clear on its own. And it usually doesn't depend on the application logic. Like, it could be really, you could try and avoid this here, as I said, if you start a new transaction. When you enter this method, that would be the only way in which you can be absolutely sure that the flush isn't required. But then you wouldn't save a lot of time, and it's actually better to just combine it here. Yeah. Then let's take another look at the slides and summarize this section real quick. So to avoid inconsistencies, always make sure to separate your join from your join fetch clause. Make sure that when you perform JPQL or criteria update or remove statements, that you clear your caches before. Otherwise, the change will happen on the database. You will just not see it in your application. When you're working with B-Directional associations, always make sure to update both ends of the association, as you saw. If you don't do that, it might either happen that Hibernate doesn't remove any records on the database, or you just don't see the change on one of the objects participating in the association. So in our example here, we saw that the author still wrote all 3 books, but the book didn't had any author assigned to it. And then the open session view anti-pattern, where by opening the session in your view layer, you get into this situation that you, one, increase the load on your database, because the database will need to open and close a transaction for your business code, and then another one for the initialization of the association, and that is a pretty expensive operation on the database side. And then you're getting into the situation that that the data that you're fetching from the database doesn't fit together. As you saw in the example, we first counted the number of books of an author, and then we fetched it later outside of the transaction context, and we got into the situation that we counted 3 books for the author, but when we tried to fetch them, there were only 2. And then the final part, you can actually also lose data. But don't worry, there are not a lot of situations in which you're at the risk of using any data. So the first one would be something that I already mentioned when we talked about flush and clear. So I said that the clear removes the records or the entity objects from the current persistence context without checking if they are dirty. And here I'm now implementing a batch, a very small one. So I'm getting all books from the database in batches of 5. In a real application, your batch size would, of course, be bigger. You would get several hundred or thousands, a few thousand records, depending on the whole structure that you're fetching and the number of database columns mapped by the entity or class and so on. But to keep it simple here, I just fetch book entities in batches of 5. And then I iterate through these 5 books, set the title to uppercase, and to save some memory, I decide to clear my persistence context after I process these 5 books. And I just hope that Hibernate would persist them, these changes in the database. But as you can see here, Hibernate did that only for a few, the last two books. So for the first 5 books, it's still lowercase. For the second 5 books, it's still lowercase, but for the last batch, it's to uppercase. And that's because Hibernate here clears the persistence context without flushing the change to the database. If we add the flush call here and run the same test case again, then we can see that now all of them are uppercase. And if we take a look at the statements that we are executing, then we can see now that we first get the first 5 books, and then we update them 1, 2, 3, 4, 5. And then we get the next batch. We update them 1, 2, 3, 4, 5. And then we get the last batch, and we update these 2. So always make sure to do a flush before clear. And the last thing I want to show you is something with cascading. So let's go to the book entity. Wait a second. No, to the author entity. And you can see I activated cascade type all on the books. So if we want to, if we are deleting an author, we want to remove the associated books. And let's say if we're removing a book, then we also want to remove the author who wrote that book. Right? We want to make our life easy. When we remove the books, the author has to go, and if we remove the author, the books of the author have to go. So You're probably not too surprised when we take a look at the log output. So at the end, let's quickly. So at the end, I get all the books from the database and print them out. Take a look at the log, then you see that we have here the here the select statement that gets all the books from the database, but we don't print any books. The reason for that is that there are no books left in the database. What happened here? You can see that we have lots of delete statements. So up here, we first get the information for the author with ID. No, we first get all the books, and we see that we have 12 books in the database. Then we get the author with ID 2. Initialize a bunch of data. And then at some point, we start deleting here. We now remove the author with ID 1. So what does Hibernate do? Well, when we were removing the author with ID 1, we told Hibernate to cascade the delete operation to the books. So Hibernate does that. A little bit hard to see here because we are now first removing everything from the book author table. See that we're removing a bunch of records here for specific book IDs, and then we're deleting the books, more books, and then we're deleting the authors, and more books, and more authors, and more books. So when we remove the author, Hibernate cascades the remove operation from the author to the associated books. So now, when we remove the author with ID 1, Hibernate gets all the books that were written by that author and tries to remove them. But if we take a look at the books, we have a cascading to the author association here as well. So we cascade the remove operation back to the authors, and if there's now a book that was written by multiple authors, then we not only remove the author 1, we also remove all the co-authors of the book, of the books that they wrote together with author 1. So we bounce from the author to the books. Now we're bouncing back to the author. Well, and now you know what's happening. We then again bounce cascade the delete operation from the authors to the books, from there to the authors, and it bounces back and forth until there are no associations that need to be removed. And well, in this example, I created my records in the author and book tables in a way that all of them are by some way connected with each other, and remove everything. So you might say, well, it's obviously a bad idea to cascade many association in both directions. And well, you're absolutely right with that, but it's actually worse. So now we have a cascade type all on the author, and we don't cascade from the books to the author. So we should remove less data than we did before, right? Right. Now we just have 13 delete statements, and we can see up here, if we just scroll up a little bit, then you can see that we delete way less data than we did before. So we did remove records from the book author table and a few books, but just one author. And that is the author with ID 1 that we actually wanted to remove. But we run into another issue. Let's go up here. I print off the books that were written by author 2, and that are the books 3, 4, and 2. You can see it here, written by author 2, author 2, author 2. Book 3 and book 2 were also written by author 1. So now we remove the author with ID 1. And if we now take a look at the books written by author 2, then we just get book 4. That is the only book that wasn't that author 2 didn't write together with author 1. That means by removing author 1 and cascading the delete operation from the author to the books, we removed all the books in which author 1 participated. That includes the one that author wrote together with other authors. And I'm pretty sure that in a real bookstore, all the other authors wouldn't be amused at all if their books get removed just because we're removing author 1. So when you are using cascading, please make sure that you have a parent-child association on which you cascade the operation. And that's the case for all kinds of cascade operations. Cascading is intended to be used on parent-child associations like an order with order positions. In this example, maybe a book with reviews. It doesn't make any sense to keep reviews of a book that no longer exists, right? So that are the situations in which using cascading actually makes sense. In all other cases, cascading is almost always a bad idea. So many-to-many associations in general are, well, I can't remember a case in which we used a many-to-many association with cascading without running into any issues. That just doesn't happen. Cascading makes sense on one-to-one and one-to-many associations. And then only if you model a real parent-child association where the child depends on the parent. In all other cases, please don't use cascading. Okay, so let's summarize this. To avoid data loss, never clear your persistence context without flushing it before you do that. Otherwise, you might have some dirty entities in your current persistence context that then just don't get flushed to the database. So that means you have your write operation in the code, but it never gets written to the database. And trust me, I had to analyze that on a few consulting projects. That's a really nasty bug where you spend a lot of time figuring out what's actually going on, because the error description that you get is, well, it looks like everything works fine, but out of these 150 records that we are changing, some just don't get changed, and we don't understand which ones. And then you start searching for the cause of that issue, and you will for sure find a clear without a flush. And the next thing you should avoid is cascading on many-to-many associations. Obviously, cascade type remove. Same with all other cascade types. That's not as bad as the cascading of remove operations. But cascading on a many-to-many association in general just doesn't make a lot of sense. Okay, then we reached the end of my presentation for today. I'm now happy to take further questions if you have any. And if you like the presentation and want to learn more about Hibernate, please take a look at my Hibernate Tips book. You can find it at hibernatetips.com. Until next Friday, so for the next, 8 days, you can get 25% off on the book as a Black Friday deal. And if you're struggling with performance issues and want to get some help with that, then take a look at my perf tester tool, which analyzes the database interactions that Hibernate performs and finds typical performance issues, tells you where they occur and how you can fix them. So yeah, someone described it as having me automatically taking a look at your code and reviewing it for performance issues. It might not be as that good right now, but it's pretty good to find the most common performance issues in your application. Okay, then if you have any questions, please post them in the chat. And in general, thanks a lot for all the questions you already asked and for the interaction that we had here in the chat. I hope you enjoyed it.
Yes, okay. Thank you for coming here, for spending with us half 1 hour. So yeah, you answer many questions, and thank you all for just asking those. I hope that someday you will come to the Wrocław to make this talk or another one in live with us.
I would love to, yeah.
And yeah, thank you very much once again, and thank you all. Have a good day.